The design of continuous composite beams involves the checking of multiple limit states for shear and bending, and in addition checking the deflections in order to comply with the design code's provisions. So at the end you come up with a section that passes all the checks. But how do you know that your section is the best section that you can get? How do you know that your design cannot be improved any further? And if so, is there any way to do it without spending a lot of time? Fortunately, ASDIP Steel has a feature where you can optimize your design without spending a lot of your time. This is Javier Encinas, and today we're going to discuss how to optimize your steel and composite beam design in ASDIP Steel. Let's get started. To illustrate how the design manager works in ASDIP Steel, I have prepared an example. This is a continuous beam. It's a 3-span beam with 2 cantilevers. It's exposed to distributed and concentrated loads in all spans. It also has some construction loads. If we go to the construction combination, we can see here the construction loads applied to this beam. And these are the final loads. We go to the at a glance tab. We can see here all the limit states. Everything is passing, the deflections all passing. Here in the design of the non-composite beam for the construction loads, everything is passing. And here at the bottom is the checking for the composite beam for the final loads. In this example, I selected a beam 24 by 62 and everything is passing. If we were checking the capacity of an existing beam, then the beam size is known and we can complete the design accordingly, as I'm doing it right here. But if the design is new, then the beam size is unknown and we can specify any beam size that complies with the design criteria. For example, in this case, I'm specifying a W24 by 62, and I can see that all the design ratios are less than 1. For example, here is 0.63, 0.60, in composite is 0.11. The deflection is very small, 0.18. So the question is, how can I optimize this design? Is there any other section, lighter section that I can use? Of course, I can go to the sections database and here specify another section that is lighter and so on. So I can do it by hand, one by one, and checking if it passes. But of course this procedure will be very time consuming. I will need to check all the ratios for that section. And if I have to do it 10 or 15 times, it's going to be very time consuming. Fortunately, ASDIP Steel has a feature called Design Manager that we can use to optimize the design very quickly. If we go to the design, then Design Manager, you are presented here with this window. In this window you specify the beam type, either a W-beam or a HSS or a pipe. Let's say that is a W-beam. Usually in building design, the space available for the structure is limited because above the ceiling you need to leave space for the ducts and pipes and all utilities. So the depth is critical usually in building design. So here you specify the limitation. What are the limits in depth that your design needs to comply with? In this case, I'm specifying that the beam has to be no more than 24 inches deep and no less than 16 inches deep. Once the beam type and the depth limitations are specified, you simply click on this button, the Find Sections button. Then ASDIP Steel will run every section within this range and will find all the sections that pass the design checks. All the sections shown in this table are the winners, are sections that meet the design criteria and they pass all the design checks. So any of these sections will pass the design. So the question now is, from this table, what is the best section that I should pick? If I want to select the lightest section in this table, I just need to sort the table by weight. I just click on this header, weight, and then the table has been sorted descending. One more click is sorted ascending. So this section at the top is the lightest section that complies with the design criteria, W16 by 45. And the ratio corresponding to that section is 0.88. And from there I can select any other section, for example, W18 by 50, the ratio is 0.7. And so on. I can select any section from this table. The top is the lightest. If I sort the table by ratio, just click on this ratio here. The section at the top, W21 by 50, is the most efficient section, which is the highest ratio less than 1, it's 0.94. The second most efficient section is W16 by 45, 0.88, and then 24 by 55 ratio 0.77, and so on. So there are several options that I could choose from. In this table, for example, I could pick W16 by 45. The ratio is 0.88, which is a good margin from 88 to 1. And it is the lightest also because it's only 45 pounds per foot. If I sort by weight, 16 by 45 is the lightest as well. So I would pick this section, W16 by 45. Once I have decided that this is the section that I want to use, just click on Select button, and this section has been transferred to your calculation sheet. So this is W16 by 45. And as expected, all these ratios are less than 1, so it's passing everything. The maximum ratio is 0.88, as we saw in the table. So this is the section that we're going to use. If we go to the Graph tab, we can see here the moments and shears for that beam. We go to the Contents tab with all the calculations in more detail. If we go to the Detail tab, we can see a more detailed set of calculations step by step with exposed formulas and also with references to the code. So everything is there for a granular checking. As you can see, it's very easy to optimize the design of a steel and composite beam in ASDIP Steel. Just go to the Design Manager and populate the table. Select one section from the table of the winners, and the properties of that section will be used in your design. With this, we conclude the presentation about the process to optimize the design in ASDIP Steel. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.